So hey everyone, welcome back to Kepler. I am Satvik. Today we are going to solve another GFG problem of the day. Today's problem is sort zeros, 1 and 2's. Okay, so given an array containing only 0, 1 and 2, sort the array in ascending order. A note is given. You need to solve this problem without utilizing the built-in sort function. Okay, so sorry. In today's problem, we have given an array such that each element of the array is either 0, 1 or 2. Now the array is the element are in random order. Now we need to provide the sorted array. So the objective is to provide sorted array, and it's been told we cannot use the built-in sort function. Okay, now there are various approaches by which we can solve this problem. First one and the most simplest one can be by directly counting the number of 0, 1 and 2. For an example, 0, 0, 0, 1, 2, let's not be 3 0 at a time, 0, 1, 2, 2, 1, 0, 1. Okay. So the first approach can be by directly counting the number of 0, 1 and 2. As the number of element, the type of element is limited, so I can directly count it in a single pass. I will keep 3 variables, count 0, count 1 and count 2. And in a single pass, I will count the number of 0, that is 2, number of 1, that is 3, and number of 2, that is 2. And in the next for loop, I can just print. First I will print 2 0, then I will print 3 0, 3 1, then I can print easily 2 2. This, sorry, I by mistake I have written 3 3. Okay, so 3 1 will be there and then 2. Okay, so this provides the sorted array, and the complexity is also big O of 2n because a single pass is required to count the number of each element, and another pass is required to print them or store inside another array. Okay, but in a follow-up, the problem states that can you come up with a one pass algorithm using only constant space? Okay, so currently our algorithm takes around 2 pass or 2n time complexity. Now the problem challenges us to solve the problem using a single for loop or a single pass. Okay, so the intuition to solve this problem in a single pass is like this. So what if let's take the same example, 0 1 2 2 1 0 1. Okay, so what if I just handle 0 and 1 0 and 2? That means if I handle 0 and 2, then 1 will automatically get sorted. If I put all the 0 in their correct position and all the 2 in their correct position, then 1 will already be sorted. So the approach should be like this. I will take the left bound of 0. I will always try to move all the 0 towards left, towards extreme left, and try to move all the 2's towards extreme right. For an example, 0 1 2 2 1 0 1. So anytime I find a 0, I will try to move it towards the extreme left. The first 0 is already in extreme left, so I will don't do anything. Then comes 1, I will don't touch 1 because if I handle 0 and 2, 1 will automatically get sorted. Okay, now 2 comes. Now I will try to move 2 towards extreme right. That means 2 will move towards extreme right and 1 will come its place. 1 2 1 0 2. Now again 2 comes. Now again I will try to move 2 towards extreme right. So it will become 1 0 1 1 1 0 2 2. Then comes 1 after this 2. Then it will come 1. I don't touch 1. After that again 0 comes. I will move 0 towards extreme left. So the array will be 0 0 1 1 1 2 2. Now coming to the approach or the algorithm which we are going to use to implement this. So we are going to only keep track of the last position of 0 and last position of 2 where we have inserted. So we can get the leftmost and rightmost value where we will be going to insert the next 0 and next 2. Okay, so we will be going to use two flags, you can say, or a pointer. Let's say for flag 0, initially it will be the leftmost because I always want all the 0 towards the left. So initially the flag 0 value will be 0. And another, the flag 2 value will be to the rightmost because I always want the 2 towards the right. Okay, flag 2 value will be n minus 1, where n represents the size of the array. Now as I traverse, let's write a for loop. A while will be better, I think. Sorry. So while my pointer be I, while I less than n, when n is the size of the array. Okay. So anytime I got a 0, these are my two pointers which I am going to use to move the 0 and 2 towards left and right respectively. Okay, so anytime I got a 0, that is your array of I is 0, that means what I am going to do. Let me write an example also side by side, so it will be much more clear. Okay, so 0, 1, let's take another example. 0, 1, 2, 0. Okay, so anytime I am going to, let's start with 1 then. So first of all, I am not touching the 1. So if array of I is 1, then I am going to do is that I will just let it be. I won't touch it. Just move I forward. Sorry. Now coming to, what if array of I is 0? What if array of I is 0? If 0, my initial flag is to F0 because I want all the 0 towards left. The first one I don't touch it. Now I comes to 0. Now what I want to do? I want to move the 0 towards left. That means in the position of F0. So I will swap F0 and array of, just swap array of I and what is array of F0, because it's the leftmost currently. I am going to swap them. That means it becomes 0, 1, 2, 0, 1, 2, 0. Now what happens? Now first of all, as I have the leftmost position is already 0, now whenever next 0 comes, I want it here. No. So I will just move my F0 towards right by a value of 1. So F0 will be plus plus. My current F0 will be here. My current F0 will be here, because anytime I get a next 0, I want it here, not here, because this position is already occupied by 0. Okay, so I increase the value of F0 and yeah, my 0 will be sorted. Then I move forward I plus plus. Okay, now the last condition. What if, sorry, what if my array of I is actually 2? What I am going to do? If my array of I is 2, then I am going to move the 2 towards extreme right. That means this position, because 2 will be at the end itself. My the pointer for 2 is F2 is now at, sorry, my pointer for 2 is at the end. So I want my 2 here. So what I will do? I will just swap array of I and array of F2. Sorry, yeah, it's F2, right? Yeah, array of F2. I will swap them. Now next, as this position is already occupied by 2, that means my current array will be around like this, 0, 1. This will be swapped. So 0, 0, 1, 2, 2. This 2 moves here and 0 moves here. So yeah, my 2 will be here. Now the next 2, whenever I get the next 2, I want it at this position. It's already 2, but even if it's 1 or something, the next 2 will always come in this position, because the last position is already occupied by 2. So I will move F2 towards left. That means F2 will be minus minus. So the value of F2 will decrease. And now one important thing, that like previous time, I don't increase my IS value, because after in this time, after I swap, For example, 0 1, let's change it a bit. 0 1 2 0 1, no changes required actually, sorry. So after this swap, that is from 0 1 2 0 1 2 0 0 1, if I swap this, so the array will be like 0 1 0. I am currently here 0 1 2 2. Okay, so why don't I move forward? Because after the swap, actually a new 0 comes, so I again need to handle this. I will again need to swap this with f0, that means towards the left. So that's why in the case of when there is 2, I won't move I forward, the loop will take care of it. That means the entire algorithm will be like, if I am again writing it, if array of I is 1, then don't do anything, just move forward. If array of I is 0, then move 0 towards extreme left, because 0 will be towards left. That means, and the left pointer is pointed by f0, so I will just swap them. So just swap array of I and array of f0. Increase the value of f0 because that position is already occupied, so the next 0 I required in the next position, so I will just increase the value of f0. Now the last case is array of I is 2, then move array of I towards the right. So I will now the right position is represented by f1, so I will just swap them, and array of f1 not f2, and I will move f2 towards left because that position is already occupied. That means the next 2 I required in the left position of f2, current f2, so I will just decrease the value of f2 will decrease. And yeah, also in this case I am going to increase I, and in this case I am not going to increase. So yeah, now let's solve an example. For example, 0 1 2 0 1 2. Okay, 0 1 2 0 1 2. Now my initial value of f0 and f1, f0 will be 0 and f2 will be the length of the array minus 1, 0 1 2 3 4 5. Okay, initially I come with 0. Okay, so it's 0. I am going to swap 0 with f0. That means the first position will be swapped with itself, it won't change it anymore. So my new array will be 0 1 2 0 1 2, and my current f0 will become 1 because I increase the value of. Now I come to 1. Okay, so when I reach 1, I don't do anything, I just move forward. Again I move, I come to 2. Okay, so what I'm going to do, I'm going to swap 2 with the rightmost value, that means which is represented by f2, that means the index 5. So I swap these two, that means the array becomes 0 1 2 0 1 2, because 2 is getting swapped with 2, so the value won't change. But now the value of f2 comes to 4 because this position is already occupied by 2. I know that. Now the next position where I want my 2 is actually left of here, so now f2 is represented by 4, the fourth index. Okay, so I move forward. Oh sorry, in case of 2 I don't move forward. Now again, so that means I again have 2. My current position of I is here, I again have 2. What I'm going to do, I'm going to move 2 towards right, that means swap it with f2. This time the 2 will be swapped with index 4 because the current value of f2 is 4. So the value will be 0 1, we swap them, 0 1 1 0 2 2. Fine. Now current value of f2 will again become 3. Okay, now I'm still at this index because in the third case when the array of I is 2, I don't move. Now the value of this index is actually 1. As it's 1, I am not going to do anything. Now I am going to move towards right. I move towards right. My current value, my current position is actually now this. Sorry. my current position is this, the value is 0. So the value array of 0, okay, my current position is 3, array of 3 is 0, that means I am going to move left. My f0 pointer is currently pointing at 1, so I am going to swap them. So these two will be swapped. F0 is pointing here, so these two will be swapped. My new array will become 0 0 1 1 2 2. I move forward. I am currently at this position. My f0 will also move towards right. So current f0 is here and current f1 is here. Sorry, f1 not f2. Current f2 is here. Now I move, my pointer is actually here. I am now at this position. So now it's come 2. Now an interesting edge case is that once I cross f2, what f2 represents? F2 represents the rightmost value and I am going to insert 2. Now once my pointer actually crossed f2, that means I have already entered the territory of 2 and all the value to the right, beginning from here to the right is already 2. So I don't need to do anything anymore. So once my traversing pointer crosses f2, we can immediately stop our exploration, because already we have crossed f2. That means every value towards the left of f2 will already be 2. Okay, so let's code this algorithm. I'm going to require two flags or 2 pointers, f1 and f0 and f2. Okay, no, let's first initialize the size of the array. Okay, so now f0 will be 0, that means it will represent the left. f2 will be length of the array -1, it will represent the right. Now as I move forward, if my array value is 1, increase your traversing pointer and don't do anything. Else if it's 0, move 0 towards left, that means swap it with f0. Sorry, not f2, it will be 1. I'm going to swap f0 with the current position. Move f0 towards right, because that position, the previous position of f0 is already occupied. Now I'm going to move the f0 towards right. f0 will increase, not f4. f0 will increase. My pointer will also move forward. Okay. And in the last case, okay, so else if array of I is 2, and also I need to check this condition, that it means that is I should be less than f2. That means f2, yeah, that means if I already crossed f2, then I don't need to do anything anymore. If I am towards the left of f2 and I have received 2, that means now I am going to swap. So I will swap array of f2 and I. After swapping, f2 will now move towards left, because this position is already occupied by 2. So I will now move towards left. So f2 will decrease, and yeah, and in the else case, just move forward, or I can also stop the exploration. Okay, so let me check it again. Array of 0, if it's 1, then don't do anything. If it's 0, then swap with f0, move f0 forward, increase the position. If it's 2 and it's less than f2, then swap, decrease f2. Else, yeah, else just move forward, or you can also choose to stop your exploration. Okay, let's compile. So there is an error. Okay, I have not initialized I. So yeah, I think it's working. Let's submit it. So yeah, it's working fine. And that's it for today's problem. Keep coding. Thank you.